Matter and energy. Today we'll be looking at chemical reactions and chemical and physical changes. So you have a study guide, it's hyperlinked. It will open up to a larger study guide for you with more information. Today we're going to focus on chemical formulas and chemical reactions. So the beginning of our activity, we're going to be looking at chemical formulas like H2O. This is one molecule of water because it doesn't have a coefficient, a large number in front of it. So it's just one molecule of water. So it has two atoms of hydrogen. That small number after the element is called a subscript. This shows you how many atoms of that element are present. So we have two atoms of hydrogen. Over here, there is no subscript, so we have one atom of oxygen. Coming down here, remember, the best evidence of a chemical change or a chemical reaction is a new substance forming. When you get a new substance, it means a chemical reaction has occurred. Some evidences of your chemical reaction, remember that mnemonic device, older city girls love their phones. Take the first letter off of that mnemonic device, and color change would be an evidence. Now, when you get an unexpected color appearing, that means a chemical reaction has taken place. So, for example, if you have something that's clear and then it comes up as being pink, you understand a color change has occurred, so a chemical reaction also occurred. It is a new substance. An increase or decrease in temperature. Anytime a gas is formed, now indication, remember, gases are odorless and colorless. So in order for a gas to be produced, you would see bubbles, fizzing, or foaming as an indication of a gas producing. A precipitate is when a solid forms and falls to the bottom of a test tube or a beaker. Odor is when you smell something completely different from what you had. And then light would be another evidence that a new substance, a chemical reaction or change has occurred. Okay, we're going to count atoms, and in this activity, you guys are going to drag and drop these boxes, but I am only going to talk in this activity so I don't have to minimize my screen. So we have a chemical formula, and we want to count the atoms of each element. So you want to think of, well, what is this chemical formula composed of? We're going to start with the first element here. We're going to count the number of atoms of that element. Since there is no subscript, there is just one atom, that one that you see. So we say we have one atom of, and this chemical symbol is potassium. So we'll drag and drop potassium here, and we'll drag and drop the number 1 right here. Let's go to our next element. Each capital letter is signifying a new element. So this chemical formula is composed of, how many atoms of nitrogen do we have? We have 1 because there's no subscript, so it's just one atom that we see there. So you'll drag and drop a 1 for one atom, and then the element's name is nitrogen. Moving on to our next element, we have 3 atoms of oxygen because we have a subscript, which is a small number after the element, indicating we have 3 atoms of that element. So you would drag and drop oxygen here, and then the number 3 there. Okay, now moving at a little faster pace, here is your chemical formula. So we're going to talk about what it's composed of. So I like to look at the element first. So this element here would be copper. And when there's a lowercase after the uppercase, that lowercase belongs to the uppercase. So I understand that this is an element. There's a subscript after that element. It's a 3. So I have 3 atoms of copper. So you'd put 3 here and then copper there. Going to our next element, we're going to look at phosphorus. So that's our element name. We can drag it there. Now, since phosphorus is in parentheses, you have to take the subscript outside the parentheses, if there is one, and multiply it by the subscripts that are inside the parentheses. So phosphorus does not have a subscript, but we still have to take the subscript outside the parentheses and multiply it by that one phosphorus atom. So 2 times 1 would give us 2 phosphorus atoms. So again, drag phosphorus here, take your 2 and drag it there. Our last element that we're going to be looking at is oxygen. So we'll drag and drop that. Oxygen has a subscript of 4, so I have 4 atoms there, but I have this subscript outside the parentheses. So I have to take that 2 and multiply it by the 4. So 2 times 4 is 8. I have 8 atoms of oxygen. So when things are in parentheses, it means that you have this substance twice. That's why we're multiplying subscripts. Okay, so let's look at this STAAR test question. It says a compound secreted by honeybees to paralyze intruders in their hive is known as 2-heptanone. The formula for this compound is shown. How many atoms of each element are in one molecule of 2-heptanone? So here is 2-heptanone. One molecule is just one that you're looking at because there's no coefficient here. So pretty much we're just counting atoms. So I'm going to minimize and grab my web paint for this question, and I will walk you through with counting atoms. So the first thing you want to do is read this chemical formula left to right and list the elements that are involved. Now you're only going to list the elements once if they appear more than once. So for example, I'm listing carbon, even though carbon appears more than once. My next element is going to be hydrogen, and again I'm only listing that once even though it's repeating. I have carbon, hydrogen, carbon. My next element that's involved in this chemical formula is oxygen. So I want to count how many I have of each. So here, this carbon does not have a subscript, so it's just 1 carbon there, 4 here, 1 here, and 1 here. So I have 4, 5, 6, 7 carbons. Okay, and then I'm going to count my hydrogens. So I have 3 here, 8 here, and 3 here. So 8, 9, 10, 11, 12, 13, 14 hydrogen atoms. And then how many oxygen do I have? I just have 1 oxygen atom, that one that I am looking at. So my answer here looks like B. 7 carbon atoms, 14 hydrogen atoms, 1 oxygen atom. Okay, so let's count atoms here in this STAAR test question. So it's saying that strontium phosphate, here's the chemical formula, is a crystalline substance used in medicine and industry. How many phosphorus atoms are represented in that formula? So they want us to only count the phosphorus atoms. Beware, phosphorus is in parentheses. Okay, and phosphorus doesn't have a subscript, so it's just 1 phosphorus, that what I'm looking at. So we want to take the 2 outside the parentheses and multiply it by that 1 phosphorus atom. So 2 times 1 would give us 2 phosphorus atoms. Okay. All right, so now we're going to look at each example of an evidence of a chemical change, and we're going to drag and drop the response cards to each question to the correct example. So whenever I see a production of a gas, I know that I must have bubble, fizzing, and foaming. Remember, gases are odorless and colorless. So in order to understand a gas is being produced, I have that bubble, fizzing, foaming. Okay, so unexpected change of color, I think that would go here because you have something that's yellow and then all of a sudden you have white. So that's unexpected. So a precipitate would be in a test tube where you're getting a solid substance forming and it starts to fall to the bottom. It could also be a cloudy substance forming as well. And then lastly, a change in temperature always involves a fire. Okay, moving on to our next activity here. I'm just going to scroll over to read our cards. So let's drag and drop the justification for these pictures. So justification here says smoke, odor, light were observed during a reaction, indicating a production of a gas. Temperature change, therefore a chemical change has occurred. So smoke, odor, light. Okay, that looks like the fireworks. So we'll put it there and see how that works out. Justification. A thick substance forms and sinks to the bottom, indicating a precipitate formed when substances are combined. Therefore, a chemical change occurred. We're getting a new substance. Justification. Bubble, fizzing, foaming was observed during the reaction, indicating a production of a gas. These two indicators are evidence of a chemical change. So remember, the best evidence always is a new substance being produced, but to understand you get a new substance, we look at those evidences being produced, like gas, light, solid precipitate forming. Here is a former STAAR test question. It says a student poured a blue solution of CuSO4 into a beaker. The student placed a shiny colored strip of zinc metal into the solution and observed the changes. The process is shown in this diagram. The student inferred that a chemical reaction occurred. What supports this inference? Explain your answer. So if the student inferred that a chemical reaction occurred, what evidence supports that? Number one, it would be a new substance being formed on the metal. Also, we could also infer that it's a precipitate too. It's a new substance forming and falling to the bottom. Okay, here let's have a look at this card. It says students in a chemistry lab conducted an investigation in which they added 4 different solid substances to separate beakers of water. They stirred the mixture for 1 minute and then recorded their observations in the table. So here's substance 1 in the water, they mixed it and they observed. Substance 2 in the water, mixed it and observed. Okay, which substance most likely caused a new substance to form when mixed with water? Explain your answer. So pretty much you're looking at which one caused a chemical reaction to occur. So here, when you see bubbles, fizzing, or foaming, you know that that's production of a gas. So substance 2 would be evidence that a chemical reaction occurred. If we look at dissolving or sinking or floating, those are all physical changes. Those are not chemical changes. Our only chemical change here is where we have a new substance of a gas being produced. Okay, nitrogen dioxide is a gas that can be generated by emissions from vehicles and factories. It can be generated by natural sources such as forest fires and microbial activity in soil. The equation for producing nitrogen dioxide is shown below. Which of these provides evidence that a chemical reaction occurs? So here you have a gas, and then another colorless gas, and now we have a brown gas. Drag and drop the red circle over the correct answer. Just having a gas present is not evidence that a chemical reaction has occurred. So you want a production, a gas being produced. So a brown gas being produced is going to be your best evidence that a chemical reaction has occurred. Okay, because these are your reactants. When they mix, they produce a new substance, which is a brown gas being produced. Okay, on your study guide, now we're going to talk about chemical equations. So in a chemical equation, you have your reactants on the left side of the arrow, and then you have your products on the right. So what happens in a chemical reaction is that these elements just simply rearrange and produce a new substance. Okay, because they switch places, they're making a new substance, but we're not adding new new elements. They're still the same elements, they're just rearranging and forming a new substance. So the law of conservation of mass states that matter can never be created or destroyed, it only changes form. And that's what these elements are doing. They're rearranging and changing form to make a new substance. So pretty much, whatever the mass of your products are, they have to equal the mass of your reactants, because we're not gaining or losing any new atoms. It's still the same elements, just rearranging places to form a new substance. So your reactant's mass is always going to equal your product's mass. So we can look and add our products together, and we understand it's 49.97. So the mass of our reactants must also be 49.97. So if we look at the law of conservation of mass, we can calculate the missing mass for each equation and dragging and drop the correct answer box to the above equations. So over here, these are your reactants. When these substances react, they mix together, they rearrange places, and they form a new substance. But remember, whatever the mass is of your reactants, your products must have the same mass. So to find that, we're going to add the mass of our products together and then subtract 7.1 to find this missing mass. So you guys will have a calculator for the STAAR test. It's built in as a tool. So you're going to be using your calculators, and I'm adding 3.38.1 plus 5.6 grams is 43.7 grams. Okay, would be my total mass here. But if this substance weighs 7.1, I have to take 43.7 and subtract 7.1. So my missing mass here is 36.60 grams. Okay, and so you would do the same over here. Your reactants, you would add the masses, 25 grams. So your products must also equal 25 grams. So what's the missing amount of grams? 10 grams. Okay, and then you'll do the other two on your Google Slides. Now we're going to discuss, is this a physical or a chemical situation or reaction? So water condenses to form water vapor. You still have the same substance, water vapor, it's just changing its state of matter. So this would be a physical change. So you would drag and drop your physical card on top here. Teeth chewing, so you're only changing the size of your food. So this is a physical change. When you chew, it's physical. Okay, Kool-Aid mixed with water. This is a physical change, because if you mix green Kool-Aid in water, you're expecting green Kool-Aid. Okay, so this is a physical change. We're not getting a new substance. Mixing vinegar and baking soda. Vinegar and baking soda causes a chemical reaction because bubbles and gas would be formed. So the bubbles and the fizzing would indicate production of a gas, so that's a chemical reaction. Copper penny exposed to the environment turns green. Now, copper is shiny, it's a metal, and so you're getting a new substance here when it turns green. So that's a chemical change. Melting ice cream is a physical change. You're only going from a solid to a liquid. So same thing here, burning a marshmallow, you're getting a new substance, you're getting that black charred material, so that's a chemical change. Frying an egg, you're getting a new substance, you're getting that white part, you can't get back that clear substance. Melting chocolate is a physical change. Chopping wood, physical change, you're only changing the size. Striking a match is chemical. Anything burning or heating a substance is going to be chemical. You're getting a new substance. You're getting light. Look at your Evans there. Light is also being given off. Boiling water. Now this is a physical change because you're only changing the state of the water. First it was a liquid, now it's a gas. All right, let's drag and drop the physical and chemical cards to match each statement. So here, substances are not altered chemically, but can change phase from one to another. That would be a physical change because you're not altering, you're just changing the phase, a solid, liquid, or gas. Substances are altered chemically to produce a new substance. That's a chemical change. You can't get back what you had. Can be combined or separated, but keep their original properties. That's physical. Okay, we're not getting a new substance. The new substance has different properties. That's chemical change. We can't get back what we had. Okay, and then lastly, we're going to finish with a STAAR test question. It says researchers are investigating processes that happen during digestion. Which answer choice describes a physical change during digestion? Any type of acid is always going to be a chemical change. That's not physical. Chewing in the mouth breaks down food. That sounds good because we're only changing the size of the food, so that could be physical. Enzymes in your saliva, that's chemical. And then bacterias are converting fiber into fats. You're getting a new substance. So your only physical change here is chewing food. Well, I hope you enjoyed your lesson on chemistry and that was helpful.